Okay, welcome back. Operations on radicals, lesson 2, multiplying radicals. Again, it begins with an investigation. So have a look at these. Have a look at these questions. It says use a calculator to determine if the following statements are true or false. So using your calculator, you can punch into your calculator the square root of 2 times the square root of 3, get some decimal number, and then punch in the square root of 6 to see if they're equal. Do the same process for A, B, C, D, and E to see which ones are equal and which ones are not. I would pause the video here, take a couple of minutes, do those, and then I will come back and talk to them. Okay, hopefully you paused your videos and you worked through those and you were able to determine that, let's get a nice color here. Let's go with blue. A is true. B is true. C is not true, false. D is true. E is false. Okay, so A, B, and D are all true, and E is false. And then based on those results, what do you think would be a rule to allow us to multiply radicals together? And the rule is basically, it's easy as that they have to have the same index. Straight up, that's all it is. A, B, and D. A is square root, B is square root, D is cube root, C is a square root times a cube root, that's not going to work. F is a cube root times a square root, that is not going to work. After that, once you've determined it is going to work because they all have the same index, you simply just multiply the coefficients and you multiply the radicands. But, and I'll state right now, simplify. You need to simplify your radicals before you do your multiplication, and you need to simplify your radicals after your multiplications if they do simplify. And there's a reason behind that. The reason behind simplifying before is that it's always easier to work with smaller numbers. You've worked with small numbers for most of your life now. You probably have a decent idea of what 2 times 2 is, but what's 200 times 14, right? Like those ones are going to be a little bit tougher. So if you can keep your numbers smaller, it's going to make the rest of the process easier. And then this part, this simplify at the end, that's no different than simplifying a fraction answer at the end. You always have to check to make sure if those fractions reduce. So if we're simplifying radicals or if we're combining radicals, we always have to check to make sure if that radical is simplified. Okay? And then basically that's all it goes down into below. Multiply the coefficients by the coefficients, simplify, multiply the radicand by the radicand, and simplify where possible. The index must be the same in each radical. So that should be your first step. Determine whether or not it's actually doable. So if we look at example number 1a, square root of 8 times the square root of 8, well, the index are both the same. It's a 2. So this is doable. This would give me the square root of 64. And you should know that the square root of 64 is equal to 8. Okay? Multiply and simplify where possible. 4 square root 5 times 3 square root 6. These both have an index of 2. So I'm going to go 4 times 3 is 12. And 5 times 6 is 30, square root 30. And then you would try to simplify 30. Well, 30 is 2 times 3 times 5. So there's no pairs in there. That is not going to simplify. So there's your final answer. Question C, 4 square root x times 3 square root y. These both have an index of 2, so this is doable. I'm going to go 4 times 3 is 12. And x times y. X times y is simply just x times y, xy. You can't multiply those together to get something funky. You can't go x times y to get z, right? So you just leave it as x times y. And then question D. -2 square root 8 times 5 square root 12. These are both square roots, but these both can be reduced to begin with. Okay, so it's going to be significantly easier to reduce these now than it would be to reduce afterwards, because the number is just going to be so big. And then after a while, you're going to get to know, hey, you know what? I've worked with square root 8 so many times, I know that that is 2 root 2. So this is going to be -2 times 2 root 2, which is -4 square root 2. And I've worked with 12 so many times that I know that that's going to be 2 square root 3. So that's going to be 5 times 2 square root 3, which is times 10 square root 3. Now I can multiply. -4 times 5 is -40. 2 times 3 is 6. 6 cannot simplify. You would be done at that point. Flip the page or look onto the next page for example 2. Example 2, expand and simplify. Square root 5 times square root 2 square root 10 minus square root 5. Again, this is doable. These all have the same index. And then I'm just going to bomb, just like I would normally bomb, 2 times 3x plus 6. Bomb this in, right? Distributive property. We're going to use our distributive property with our radicals. Square root 5 times 2 square root 10 is going to give me 2. Remember, there's a 1 here. We never write. 2 square root 50 minus, and then square root 5 times square root 5 is square root 25. Well, I know the square root of 25 is 5, so that one's easy. It's not an equal sign either. It's a minus 5. But square root of 50, you should almost know now, is 2 times 25. That's a perfect square. So this is 5 square root 2. This is 2 times 5 square root 2, which is 10 square root 2, take away 5. And I can't combine that any further. That's exactly where that stays. There's no radical attached to the 5 anymore. So I would have to leave that as it is, simplified. Question B. 2 square root 5 times, and in brackets, 3 square root 45 minus 8 square root 5 plus 3 square root 20. Before I get rolling here, I'm going to simplify the square root 45. Square root 45, 45, and again, your scrap work can be done somewhere else. It can be done within the question. 45 is 5 times 9. Well, 9 is a perfect square, or 5 times 3 times 3. 3 is going to pop out. 3 square root 5. So this is 3 times 3 square root 5. And I'll do the intermediate step. 2 square root 5 times 3 times 3 square root 5. Right? Minus 8 square root 5 plus, well, square root 20 is 2 times 2 times 5. So that's 2 square root 5. So that's going to be 3 times 2 square root 5. Ooh, look at everything on the inside of that bracket has the same radicand and the same index. So I can simplify all that together. 2 square root 5 before even multiplying. 3 times 3 is 9 square root 5 minus 8 square root 5 plus 6 square root 5. And I can combine that. 9 take away 8 is 1 plus 6 is 7 square root 5. And now I can simply multiply by my 2 square root 5, 5 not 2, 5 not 2, on the outside. 2 times 7 is 14. 5 times 5 is square root 25. Well, the square root of 25 is 5. 14 times 5 is equal to 50, 60, 70. I think 50, 60, yeah, 70. Okay. So by simplifying our radicals beforehand, we were able to simplify this entire bracket down to a simple single radical. Made our process significantly easier. I would challenge you, if you want to try and do that without simplifying first. Use your distributive property and bomb these in. See what happens and see how hard that is. Okay. Example C, I'm going to save for in class. And And example D. -4 square root A times square root A minus 9 square root B. Again, all our radicals are the same. Our indexes are the same. So this is going to be bomb this in here, bomb this here. This is going to be -4 square root A squared minus, not minus, plus, -4 times -9 is positive 36 square root AB. That's a 6. There we go. Oh, it was a 6. 6. Well, the square root of anything squared is itself. So this is now just -4A plus 36 square root AB. And I can't do anything else. Do not try and combine those further with some funky rules that you're making up, because that's as far as it goes. -4 apples plus 36 square root apples, bananas, right? They're different. You can't combine them. Question 3. Write and simplify an expression for the area of each shape. Well, the first shape is a rectangle. Our area is equal to length times width. Length times width. And our question B, this is a square. Area is equal to side squared, which is just side times side, right? So if we're going to multiply these together, 4 plus square root 6 times 7 minus square root 6. If this looks at all familiar to you, it might look like this: x plus 2 times x plus 3. Hopefully you remember your distributive property. You're going to multiply these together, first outside, inside last, our FOIL, right? Binomial distribution, simple term, FOIL. So I'm going to multiply 4 times 7, which gives me 28, and 4 times -√6, and √6 times 7, and √6 times √6. So 4 times 7 is 28. 4 times -6 is -4 √6. √6 times 7 is +7 √6. And √6 times -√6 is -√36. Well, square root of 36 simplifies. This becomes a 6. So it's 28. And then -4 plus 7 is +3 square root 6. And then -36 is 6. Square root of 36 is 6. I can combine 28 and 6. 22 plus 3 square root 6. And it doesn't matter which order you write that in. You could write 3 square root 6 plus 22. Makes no difference. And I think I'm going to save this one also for in class. Oh, I can't spell in. I've spelled in that way every time. In class. I'll do that one in class as well. I may forget though, so somebody may have to remind me. Now, part of the reason why we need to know how to multiply our radicals together like this, especially binomials, is because when we get into further work with radicals and rational expressions, we need to simplify radical expressions, because we can't have radicals in the denominator of a fraction. So although we're not going to deal with it right now, the process to get rid of radicals in the denominator of a fraction, there's two. One is for monomials, the other one is for binomials. Binomials, we multiply by the conjugate. Okay, so that's why this term is coming up now, multiplying conjugate binomials. Well, what's a conjugate binomial? Number one here, this is an example of a conjugate binomial. Square root 5 minus square root 2, square root 5 plus square root 2. Exact same radicals. One's plus, one's minus. It doesn't matter which one's plus, which one's minus, as long as you have 1 plus, 1 minus. So this one is plus minus the other way around. Okay. So you can create conjugates. Let's flip over to the next page real quick. We can create conjugates just by changing that sign. So if we look at example 4, write the conjugate and then multiply. Well, let's write the conjugate before we multiply. If this is 4 root 6 plus 3, then the conjugate is 4 root 6 minus 3. Question B, if this is our binomial, -3 root 11 plus square root 2, then our conjugate is -3 square root 11 minus 2. The only thing you change is this symbol, right? And then our last one, 5 root x minus y. Our conjugate would be 5 square root x plus root y. You just change that symbol. Okay? So that's multiplying by the conjugate. And a funky thing happens when you multiply by the conjugate. So if we go back to this example in the previous page, 5 minus root 2, square root 5 minus square root 2 times square root 5 plus square root 2. Watch what happens when we multiply these two together. 5 square root 5 times square root 5, square root 25. Square root 5 times root 2 plus square root 10. Minus root 2 times root 5 minus square root 10 minus root 2 times times square root 2 is minus square root 4. Square root of 25 is 5. Square root of 4 is 2. Plus 10 plus square root 10 minus square root 10, those cancel. So I'm just left with 5 minus 2. 5 minus 2 is 3. So when we multiply by the conjugates like this, it helps to reduce the radical symbols within our questions. And in actuality, it takes them right out. So if we had that in the denominator of a fraction, we'd now be happy because we wouldn't have any radicals in our denominator. And that's the whole idea. Okay. Question 2. 2 square root 7 plus 8 times 2 square root 7 minus 8. 2 square root 7 times 2 square root 7 is 4 square root 49. 2 square root 7 times minus 8 is minus 16 square root 7. 8 times 2 root 7 plus 16 square root 7. And then 8 times 8, so I did that the wrong side. There we go. 8 times 8 is minus 64. Plus and minus 16 square root 7, those cancel, they disappear. 4 times 40, square root of 49 is 4 times 7, and then minus 64, which is 28 minus 64, which is equal to negative 36. No more radicals. That makes us happy. Over the page, we've already written out our conjugates. So let's do the multiplication. You know what? I think I'm just going to do C. If we have some time, I might come back to those in class. Okay, but I think you get the idea. But if we do C, 5 square root x minus square root y times 5 square root x plus square root y. 5 root x times 5 root x is 25 square root x squared. 5 root x times square root y is 5 square root x y. Root y times 5 square root x is minus 5 square root x y. And root y times root y is the square root of, that's minus square root y squared. Plus 5xy, plus square root 5xy minus square root 5xy, those will cancel, they will disappear. 25 times the square root of x is 25x. Square root of y squared is y minus y. There is your answer. Okay, so I think that's enough examples. If not, then maybe we'll do more in class. We've got a couple there if we need them. Make sure you're checking Scholantis to see what questions are suggested work for you to do, and we will see you next time.